Our ability to communicate, to express ourselves through written, spoken, and visual language is a fundamental aspect of what makes us human. If we want to create an artificial intelligence capable of augmenting human ingenuity, we must start with language. Innovation hinges on our ability to see the world differently, breaking boundaries and looking in unexpected places to help solve some of the world's toughest challenges. As humans, we master language by making connections. It takes us many years to learn about the relationships between words and the importance of context. There is hidden complexity in seeing an object and then identifying and accessing the word or words needed to describe it, and then doing this in multiple languages. Now, imagine what it might take to understand a sentence, a whole Wikipedia article, or an entire novel. In the past, we used rule-based systems to try to mimic this understanding in machines, but there was no genuine language comprehension at all. Later, we taught these machines how to model language in a mathematical way with vectors. Still, this didn't really give our machines a rich understanding of conceptual relationships. What was missing was context. Today, our language models are learning language by essentially reading the book through an approach called self-supervised learning. It works like this. We give our model a huge amount of text, and as it processes the text, we ask it to predict words based on the surrounding context. As the model does this hundreds of millions to billions of times, it starts to build an understanding of the underlying language concept and grammar. We think of the development of AI similar to how we think of the development of the human brain. Synapses between neurons build cognitive capabilities in humans, and in AI, these neural connections are called parameters. A year ago, the largest AI models had around 1 billion parameters. Our latest model, called Turing, has 17 billion. We anticipate that the trend will continue into the hundreds of billions of parameters and then trillions. The only way to train a model with billions or even trillions of parameters is with large-scale infrastructure composed of clusters of hundreds to thousands of machines with specialized hardware, all interconnected by high-bandwidth networks. The Azure cloud provides us with such clusters. We then need to distribute the training of the model across all of these machines. Over the past year, we have developed optimization techniques that reduce the resources that we need and still train models faster on the same infrastructure. General language is sometimes not enough to support the tasks needed. Let's say you give a human a foundational education, where they gain a general understanding of the world. This is similar to how we develop our AI models. We start with a high school level model, which has learned from all the data available on the internet. We send this baseline model to build on its abilities in specific domains. For example, the productivity domain for Office, the business domain for Dynamics, or the professional domain for LinkedIn. As our language model learns from domain data, it does so within the context of each organization in a privacy-compliant manner. An emerging generation of even larger models is now learning from this data and functioning in a more generalized way, combining language, images, video, and speech. Even with these amazing recent achievements, the reality is AI is still in its infancy. For example, we're still far from AI that can use common sense reasoning to draw conclusions. Every time we reach a new AI frontier, we realize we can do better. As research advances and we magnify human intelligence with artificial intelligence, we may gain a clearer and deeper understanding of ourselves and of one another.